right, so thank you so much for working through the Desmos activities. So now you know a little bit more about vocabulary, I guess more formal words that we're going to see and use. So just wanted to reinforce that, and then we'll take a look at some examples. So when we were doing the polygraph, right? So if you had a parabola that looked like this, I think a lot of us were using words like smiley, does it look like a smiley face? Does it face up? So the vocabulary that we were introduced in the Desmos activity included words concave up. So this parabola would be actually concave up. And so you feel good about yourself. This is something that we talk in calculus. So you are getting to know some fancy calculus vocabulary here. Okay, so this parabola is concave up, and while this parabola is going to be considered concave down. So concave down. All right, so let's go back here. So when somebody asks you about the y-intercept, they are asking you about the place where your parabola crosses the y-axis. Again, this is just a general graph, so we don't have a specific one. And I meant to say y-intercept, so I'm going to do that. Okay, and for this parabola, we have two different x-intercepts. They're right here. And two new words for us. One word was the vertex. So the vertex is the slowest point right here. Right, so this is going to be called the vertex. And a vertex is just this is the point where your parabola is the lowest or the highest. So in this case, it's going to be considered the min, right? Because that's your lowest value, or the lowest point on your graph. So think about if you are a point in your graph and you kind of travel along, where would you be the lowest? Okay, and then axis of symmetry is this line, and I'm gonna later make you a little video, because it's hard to do on a computer, but it's literally like if you fold your parabola, it's gonna be where the two parts are identical. It's gonna be the fold itself is the line of symmetry. Okay, and so line of symmetry. And the line of symmetry is a vertical line, so it is always going to look like x equals a value, right? So we don't really know the value. We know it's positive here, but I don't know the number. But if somebody does ask you about axis of symmetry, you are surely going to say x equals some number. All right, so this parabola has, again, this is your y-intercept, and we don't have any specific details. So these are your x-intercepts. And let's see, we have a vertex right here. In this case, our vertex would be the highest point. So if you imagine being on a roller coaster, that would be the highest place you can get to. So this is your max. And we have our axis of symmetry, which is the line that cuts your parabola into two perfectly symmetrical parts. So this is your axis of symmetry. And it's going to have an equation of x equals a number. All right, so now that we kind of took a look at these two very general pictures, we're going to get more specific, and we're going to take a look at this one graph right here. Right, so now we actually have some specific values, so let's take a look. All right, so the first thing we asked to do is find, well, actually, I'm going to come back to domain and range, right? So let's do all the things we just spoke about. So vertex, in this case, right, my parabola is concave down, so I am going to look for the highest point. This is your vertex, so it would be 4, 1. Remember, it's a point. The max or min value, so think of it as it's always the y value. So it's kind of like what's the highest y value that you can get to. If you think of physics and you're throwing a ball up in the air, it is going to follow this path of a parabola. And if somebody asks you what's the maximum height, essentially you would be finding the maximum value, right? So it's only the y value. So I just interested in the y value. So we're going to say 1, and I could see this as a maximum, so I'm going to circle the maximum. My axis of symmetry is the line that cuts my parabola in half, and it's always going to go through your vertex. So x equals 4. My x-intercepts looks like I have 2 of them. So remember, those are the places where we cross the x-axis. So 2, 0, and 6, 0. I have 1 y-intercept. Remember, that's the place where you cross the y-axis. So 0, negative 3. And the zeros come from your x-intercepts. They are the x values that make the y value 0. So if I look at my intercepts, the first one is 2, 0, which means x equals 2, right, is my first 0. And then I'm going to look at my other x-intercept, and that's going to give me my second 0. All right, so let's go back to this discussion of domain and range. It's been a while. So domain answers the question about what x values are being graphed, or what x values can be substituted into the function, or can be inputs for this function. And if you notice, your parabola goes all the way to the left and goes all the way to the right. So essentially, I can get to any x value on my graph as long as on my coordinate grid, right, on my coordinate space, as long as I can go all the way to the right and all the way to the left. So I'm actually going to say all real numbers. And there's this fancy schmancy symbol if you don't feel like writing out all real numbers. You're more than welcome to use that. And the range is the last thing I'm going to look at. Answers the question as to what are the y values that are being used, right? So if you imagine being a point traveling on your parabola, you want to answer the question as to like what are all the y values that those points can be. And if you notice, right, the highest y value I can get to is going to be 1. So I can be anywhere below 1, right? So I could travel along my parabola, but the highest point I can get to is 1. So we're going to say that here's 1 and here's the y value. Since 1 is the highest, it has to be greater than or equal to the y values, right? Because 1 is the largest value it could be. So that is it for this example. So let's take a look at the one more and then we're done. So this parabola is concave up, right? So it's facing upwards. There is your calculus word for the day, or second, right? Concave up, concave down. So domain. Again, this is a parabola. It goes all the way to the left and all the way to the right, and it's getting wider. So I'm going to be able to get to any x value that I wish. So I'm going to say all real numbers. My range is going to be the list or all of the possible y values that I can get to. So my lowest y value is going to be -4. So my lowest y value is going to be -4, so I can be anywhere above it. So if I'm comparing my y values and the -4, the -4 has to be the lowest or the smaller value. All right, my vertex is this point right here. It's going to be at a location of 1, -4. Since my parabola is concave up, I am going to have a minimum value or the lowest point, and the value of that lowest point is -4. Remember, it's just the y value. My axis of symmetry is going to be the vertical line that cuts through my parabola perfectly in half. So it's going to be at x equals 1. Looking at this graph, I could see that I have 2 x-intercepts. One of them is a negative x-intercept, so -1, 0. And the second one is 3, 0. I have 1 y-intercept of 0, -3. And my zeros are going to be two x values. One of them is x equals -1. Remember, it's the x value that makes the y value 0. And my second 0 is going to come from this x-intercept, and it's going to be x equals 3. And that's it. So now you know all the academic vocabulary there is to know associated with parabolas. And tomorrow we're going to spend the day just practicing identifying things and graphing parabolas with specific key features. Thanks again.